Hello, my beloved viewers. It's my hope that you are really doing well. Welcome to our today's class. It's our first lesson on the 10th topic of Form 2 work, which is called fluid flow. So as usual, let me start by giving you the quote of the day, which states that the start is what stops most people. Don't be most people. So we shall discuss that quote at the end of our class today. So today we are looking at fluid flow, and maybe let's start by defining what we mean by the term a fluid. We start by the definition of the term a fluid. And we are saying that a fluid can be defined in various ways. For example, a fluid can be defined as a substance having particles which easily move and change their relative positions without a separation of the mass. Or a fluid can as well be defined as a substance or a body whose particles move easily among themselves. So those are the definitions of a fluid. But in this particular chapter, we'll simply say that a fluid refers to both gases and liquids. That is, substances which are capable of flowing or whose particles can easily be separated or interchanged from one position to another. And in that case, we are saying that solids will never be fluids, because we know that in solids, particles are closely packed together and they are restricted for movement. That is, they can only vibrate from one point to another. Therefore, we are saying that liquids and gases will form fluids but not solids, simply because particles in solids are usually very fixed together. So we are saying that fluids refers to gases and liquids. Then when we talk of a flow is just the movement or simply the movement of particles from one point to another. That is what we call a flow. Therefore, when we talk of fluid flow, we'll simply be talking of particles of some substances moving from one point to another, and in this case the substances include the liquids and the gases. So a fluid flow a fluid flows as a result of pressure difference. That is, when the pressure of particles at one point, maybe say point A, is greater than the pressure difference at another point, maybe say point B, then in that case the fluid will flow. Otherwise, if the pressures are at same at point A and at point B, then in that case the fluid won't flow. So a fluid flow only occurs or results whenever there is a pressure difference between 2 points of that particular fluid. Example of fluid flows include the flow of water along a riverbed. Then another example is the flow of hot water in central heating systems, and also the convectional currents. So convectional currents actually describe a fluid flow, because remember that for there to be convectional currents, that means the temperatures of the particles in that particular fluid have to be different, such that the particles at the lower part of of that particular container will be heated, leading to an increase in their temperature, and therefore their density reduces. Remember, when the density reduces, such particles will float, hence moving upwards, and the particles that were on the upper side of that particular fluid will move downwards. For example, if it is water, the particles will move downwards because of their greater density, hence forming what we call convectional current. So for there to be a fluid flow, there must be a pressure difference, or to some extent we can also talk of a temperature difference, because a temperature difference will lead to a pressure difference. That is courtesy of what we call the pressure law that we'll look at in the last topic of Form 3 work, which is called the gas laws. Then, having defined a fluid and fluid flow, also let's look at what we are calling viscosity. Viscosity simply refers to the internal friction experienced by a flowing fluid. The internal friction experienced by a flowing fluid. So in layman's language, we are simply saying that viscosity is that particular internal, the ability of the particles of a fluid to resist a flow or to resist motion. So that is viscosity. So in simple terms, we are saying that viscosity is the resistance, or the resistance offered by the particles of a fluid to a movement, to any movement. But in physics, we define viscosity as the internal frictional force experienced by a flowing fluid. So the term viscosity is from the term viscous, and we say that a given substance or a given fluid is viscous if it is resisting the flow. For example, if you compare the viscosity of porridge and maybe water, you will find that they are different, such that porridge will always be more viscous as opposed to water, simply because porridge has more density and therefore their particles are closely packed together and therefore they won't move faster, therefore offering a higher frictional force. Because remember that frictional force is simply the force that tends to oppose the relative motion or the intended motion. So if a given fluid has more internal frictional force, it means it has more viscosity. That is, it will have a higher ability to resist the movement or the motion of that particle, the particles within that particular fluid to flow. So viscous fluids will always have more density and will always cause the fluid to flow at a smaller rate. And you have given examples of porridge and water, such that the water particles have less internal friction and therefore they flow easily and therefore they are said to be less viscous. But the particles of the porridge have more density, or even the oil. Also the particles of oil have more density and therefore they experience a higher internal frictional force and therefore their flow is resisted. Therefore the particles of porridge and oil are said to be more viscous as compared to the particles of water. Then maybe in summary, you have just said that the term fluid refers to both gases and liquids, and a fluid flows as a result of pressure difference. We have given examples of fluid flow, and you have said that the study of moving fluids is very important because of their varied applications in day-to-day life. For example, we look at the application of fluid flow in dynamic lift, that is on aeroplane wings. We'll also look at the other application which involves the working of paint, spray gun, and also the Bunsen burner, etc. Next, let's look at the types of fluid, the types of flow, that is the types of fluid flow. And the types of flow, there are three. We have what we call streamline flow, which is also called the steady flow. We also have what we call the laminar flow, and the other type we look at, which is called the turbulent flow, So let's start looking at the streamline flow, or what we are calling the steady flow, So maybe for us to understand that, let's start by defining what we mean by a line of flow, And you are saying that a line of flow simply refers to the path traced by all particles passing through any given point in a fluid having the same velocity. We are saying that a line of flow refers to the path traced by all particles passing through any given point in a fluid having the same velocity. So that is the line of flow. Then a streamline is defined as a curve whose tangent at a given point is along the direction of the displacement of the fluid particles at that point. So that is what we are defining as a streamline flow. So as you can see in my diagram here, this is my streamline flow moving from maybe a velocity v1 to a velocity v2 to a velocity v3. So this particular curve, and you can see the tangent, that is, the tangent is usually a line that cuts a given a curve at only one particular point, that is on its circumference. So you can look at this particular tangent here, and we are saying that the tangent is in the direction of the velocity of the particle, such that the particle is moving from the left hand direction towards the right hand direction. So this arrow shows the direction in which my particle here is moving. So the particle moved from this point A to point B to point C. So actually the particle is advancing from velocity v1 to velocity v2 to velocity v3, and we are saying that a streamline is defined as this particular curve, that is the curve whose tangent at a given point is along the direction of the displacement of the fluid particle at that point. So that is our streamline. Alternatively, you can simply say that a streamline, you can also define it as a path followed by a fluid particle. That is, there is a very close relationship between the line of flow and a streamline. But essentially, we have said that a line of flow will refer to the path traced by all particles passing through any given point in a fluid having the same velocity, and you have said that now the streamline will refer to a curve whose tangent at a given point is along the direction of the displacement of the fluid particle at that point. So get those two definitions well. Then whenever, that is when the streamline and the line of flow coincide, the flow is steady or streamlined. So a flow is said to be steady or streamlined whenever the streamline and the line of flow coincide, that is when they coincide. So when the line of flow, for example, if this is my line of flow, which is the tangent, they coincide, that is at this particular point, at point V2. When the streamline and the line of flow coincide, to coincide simply means to occur at the same point or to occur simultaneously. So when the streamline and the line of flow coincide, then they form a flow called a steady flow or a streamline flow. A steady flow or a streamline flow. Then next we look at what we are calling the laminar flow. Laminar flow again has a very close relationship with a streamline flow, such that we are saying that a laminar flow will always be formed whenever there is a steady flow or a streamline flow. And we are saying that a moving fluid has many streamlines or the layers. Like if you consider my fluid which is moving in this particular pipe, that is, it has layer 1, that is the pipe that is outside. Then we also have the layer, that is the first layer, that is layer 1, the inside part of the pipe, and also the outside layer, which is our layer 2. So a fluid usually moves with very many layers. For example, here we are considering one layer and the other layer, and you can see the particles of the first layer, that is the first layer, its particle or the streamlines are represented by V1 and V1, but the second layer, its streamlines are represented by V2, V2, and also the V2. That is, the velocity of the streamlines of the particles in the outer layer are represented by V2, and the velocity of the particles in the streamline of the first layer, we are representing them by V1. Now, how do we define a lamina then? So a lamina will always be defined as, that is, the flow is said to be laminar if the particles in a given streamline or layer have the same velocity, which may be different from other particles in the adjacent parallel layer. So that is what we say to be a laminar flow. So we are saying that a flow is said to be laminar if the particles in a given streamline or layer have the same velocity, which may be different from other particles in the adjacent parallel layers. So for example here, consider the two layers, that is the layer 1 and the layer 2. So if a flow is in such a way that the particles in a given streamline or layer have the same velocity, for example, if the velocity of this particle here and this other particle here, that is, remember, these particles are under the layer 1, if they have the same velocity V1 and V1, then the velocities of these particular particles in layer 1 or of the streamline in layer 1, if the velocities V1 and V2 are equal to or they are different from the velocities of the particles within the streamlines of layer 2, if the velocities are the same or different, then this particular whole flow, which is formed by layer 1 and layer 2, is said to be laminar. So if the velocity of the particles in layer 1 are the same as the velocity of the particles in layer 2, or the velocity of the particles in layer 1 are different from the velocities of the particles in layer 2, then this particular flow is said to be laminar. So for a laminar flow to occur, we must have different layers such that the particles in the first layer have the velocities which are different from the particles in the second layer, or the velocity of the particles in the first layer have a velocity which is similar or identical to the velocity of the particles in the second layer. So essentially a laminar flow is simply a streamlined flow, only that now a laminar flow we are considering the different layers of that particular flow. But in the streamlined flow we are only looking at a specific layer, or maybe a given streamline, or is simply one streamline, or streamlines that belong in the same layer. But when we talk of a laminar flow, we are looking at streamlines that belong in different layers of the same fluid. So maybe in summary, I've said that a flow is said to be laminar if the particles in a given streamline or layer have the same velocity which may be different from other particles in adjacent parallel layers. So that is the definition for a laminar flow. So again, also we can also have this can also represent laminar flows, provided this is V1, V2, this is V1, V1, V1. That is, the velocities are the same for this particle at this point, also at this point, at this other point. Then you have different another particle here, maybe in a different layer, another particle here in a different layer, another particle here in a different layer. So provided that these particular layers they belong to a similar fluid, then this forms a laminar flow. That is, if the particles of the streamline in one layer have the same velocity as the particles of streamline in the second layer, same velocity with the particles of the streamline in the third layer and in the fourth layer, then that flow is said to be laminar. Also, if the particles in the first layer have a velocity which is different from the particles in the second layer, having also a velocity which is different from particles in the third layer, and a velocity which is different from the velocity of the streamline of particles in the fourth layer, then that flow is also said to be laminar. But remember, for streamline, the particles must have the same velocity. That is unlike in the laminar. So maybe if someone asks you to give a difference between a streamline flow and a laminar flow, you will simply say that for streamline flows, the particles belong in the same layer and they are flowing at the same velocity. But for laminar flow, particles can be belonging in different layers and flowing at different velocities. So that is the difference. That in laminar flow, particles can be flowing in different layers at different velocities. But in streamline flow, particles must be flowing at the same velocity for them to be considered as to be in streamline. Also, maybe in summary, someone can also define a streamline flow as a flow in which that is, a streamline flow can also be said to be a steady flow or an orderly flow or a uniform flow. And a streamline flow occurs when the fluid particles that pass any given point follow the same path at the same speed, or they simply have the same velocity. Because remember, velocity puts into consideration the aspect of what? Direction. So that's the difference between streamline and laminar. So for streamline, particles in different layers must be flowing at the same, that is, particle belong in the same layer and they are flowing at the same speed. In laminar flow, particles may belong in different layers and flowing at different speeds or different velocities. Although for laminar flow, if also the particles belong in different layers having the same velocity, they are still considered as laminar flow. Yeah. So next we look at what we are calling streamlined bodies, and you are saying that a streamlined body is just a body that offers less resistance to the flow of a fluid. For example, this particular body here, when the fluid comes, it simply moves on the upper side, which is very smooth, and it transitions to the other side, that is smoothly. So a body is said to be streamlined if it offers very low or even negligible resistance to the flow of a given fluid. And remember, a fluid can be air or a liquid. A fluid can be air or a liquid. But particles will be considered to be non-streamlined bodies if they are offering a lot of resistance to the flow of that particular fluid. So for example, in this particular diagram here, this is still a streamline flow. Why? Because particles are still flowing in the same path and at the same speed. That is, at any given time. That is, we are saying that streamline flow, here the particles are moving. That is, the particles in a streamline flow, the particles will always be passing any given point at the same path and at the same speed, and no aspect of flow changes with direction. That is, changes with the time. Sorry, let me just repeat what I've said. I've said that we say that a flow is streamlined if the fluid particles passing at any given point follow the same path and at the same speed, and also when no aspect of the flow changes with time. When no aspect of the flow changes with time. But we will see for unsteady or turbulent flow, it will be exactly the opposite of the streamline flow. So for this particular body here, as we consider this particular streamline body here, it requires little effort to move and has no eddies behind it. That is, when a fluid is flowing along this particular particle, no effort or very little effort is required to flow past it or to move past it, because the edges are not as sharp. The edges are smooth, so the particles will easily flow along it or move past it with very minimal resistance, and no eddy currents form behind that particular flow or behind that particular particle. So such a flow or such a particle is said to be a streamlined body, and the flow is said to be a streamline flow. Then the other type of flow is what we call a turbulent or unsteady or a disorderly flow. And when we talk of a turbulent flow is defined as a flow in which the speed and direction of the fluid particles passing any point vary with time. We are saying that a turbulent flow, this is a flow in which the speed and direction of the fluid particles passing any point vary with time. For example, you have a very good example here. As you can see, this particular body here, it has sharp edges. That means it will be offering a very high resistance to the flow of this particular fluid. For example, if it is air or maybe a liquid, for example, water. So we are seeing that for turbulent flows, the bodies are non-streamlined, such that they offer, remember, some non-streamlined bodies will always offer very high resistance to the flow of that particular fluid, if it is a liquid or maybe a gas. So non-streamlined bodies will always be defined by very sharp edges, as opposed to streamlined bodies which have very smooth edges that allow continuous transition of the fluid or offers very less resistance to the flow of the fluid. So for non-streamlined bodies, we'll always have some sharp edges which offer very high resistance to the flow of that particular fluid. And I've defined turbulent flow as a flow in which the speed and direction of the fluid particles passing any point vary with time. Alternatively, you can define a turbulent flow as a flow in which the velocity of the fluid particles passing any point vary with time. Because remember, when we talk of the velocity is a vector quantity, so it puts into consideration the aspect of what? Magnitude and direction. So in short, you can just define a turbulent flow as a flow in which the velocity of the fluid particles passing any point vary with time. They vary with time. And as you consider this particular body here, it will require more effort for the fluid to flow past it, and it requires more effort as compared to this other body that was in the streamline flow up there, and it also gives rise to more eddies. So as you can see, the fluid is flowing somehow smoothly here because of some edge here, but because of the sharp edges at the ends, actually the flow of this particular fluid is very highly resisted. When the flow is resisted, it means it will result into eddies. That is, the speed of the flow of the fluid will be resisted, or the speed of the fluid will be very, very low, resulting into eddies. So we look at more about the eddy currents at a given topic in Form 4. So it results in formation of eddies such that the flow of the fluid stops at this particular point. So at this point, actually the fluid is stationary. As you can see, the direction of the fluid particle or of the streamlines is changing, such that the fluid was moving towards the right hand direction, but at this particular point the fluid is moving towards the left hand direction. So you can clearly see that the direction of the particles is changing with time. So such a flow is called turbulent. If you compare it with the streamline one, the direction of movement of the particles was to the right. At this point, the particles are moving to the right. At this other point, the particles are moving to the right. So as you can see in streamline flow, that is when a streamline body is used, the direction of the particles is the same, that is towards the right hand side throughout the flow, as opposed to in turbulent flow, whereby the direction of movement of particles is changing. For example, here it was moving towards the right hand direction, this one towards the right hand direction, but at this point the direction of movement of particles is towards the left hand direction. So a flow in which the velocity, that is the direction, that is a flow in which the velocity of the fluid particles passing at any point varies with time is called a turbulent flow. So remember, when you talk of the velocity, we are talking of the direction. So here we shall have a lot of eddy currents. The same case here, you can also see that the shape is non-streamlined because it has some sharp edges here, such that these edges tend to reduce the velocity at which the fluid is flowing, leading to formation of eddies. Although this one will have more eddies as opposed to this because its edges are more sharper. So you can see it gives rise to 1, 2, 3, 4, 5, 6 eddies, but this particular flow results to 1, 2, 3, 4 eddies. So actually, the sharper the edges of your non-streamlined body, the more the resistance it offers to the flow of the fluid, the more the eddies will be formed, the more the eddies. But the less sharper the edges of your non-streamlined body, the less eddies it will result in. So for this particular body here, non-streamlined body here, it actually results into, it requires more effort than A. That is, for the fluid to climb this particular body here, you will require more effort, that is as compared to A. But of course, this one here, you will require a lot of effort for this particular fluid to move past those edges for it to continue flowing. So this one will as well result into it would require more effort than in A, that is than in the streamlined one, but less effort than the one in the sharper, very sharper edges. Lastly, we look at the shapes designed for streamline flows, and we are saying that shapes suited for streamline flow are designed in such a way that they easily cut through the fluids and reduce the formation of eddies behind them. So this reduces the resistance to their motion. So examples of streamlined bodies are this particular car here. So you can look at my moving car here. So you can see it is made in such a way that the edges are very smooth. The edges are somehow curvy. So the edge also here is very smooth. The edge here is very smooth. So this leads to alignment of the fluid or the eddy current, the streamlines of the fluid to move continually, and as you can see, it does not result to any eddy current. So this is what we are calling a streamline body. That is a body that offers very, very low resistance to the flow of the fluid, So, so the shapes tend to reduce the resistance. They tend to reduce the resistance to the flow of that particular, maybe if it is a liquid or a gas. Also, the other streamline body is a moving aeroplane. That is, the aeroplanes are made in such a way that their edges are very smooth, such that they allow the flow of air, which is the fluid in this particular case, to flow continuously. So such bodies, we call them streamline bodies. So maybe somebody can ask you, why are streamline bodies maybe made with less sharp edges? So the reason is simply to reduce the resistance of the motion of the fluid. So when the resistance is reduced, actually the fluid, that particular body continues flowing very smoothly. Even when you consider the shape of something like a fish, you realize that the fish usually has a shape similar to this one. That is a shape that is that it has no sharp edges to resist the motion. That's why a fish is able to swim in water easily. Also, some birds, a lot of birds usually assume this particular shape. That means that they can easily pierce through the layers of the air, which is the fluid in this particular case, hence flowing easily. So shapes suited to streamline flow are designed in such a way that they easily cut through the fluids and reduce the formation of eddies behind them. So this reduces resistance to their motion. So other examples include the ships, we have the submarines, the rockets, the fish, and most birds. So if you try to look at the shapes of these particular bodies, you realize that the shapes usually have very smooth edges, hence they can easily flow in those particular fluids. Then we also look at the effect of speed of flow on streamlines, and for us to understand that, let's consider this particular diagram here. So so in this particular diagram, we have it is the reservoir A. We have the reservoir A here, which reserves the water or stores the water. So the reservoir A contains the potassium permanganate solution. So remember the color of potassium permanganate, I think it's usually pink, which is released in controlled amounts into the water flowing through a cylindrical jacket, that is a cylindrical glass jacket C by a fine jet B. So this is our glass tank, which we are calling the jacket C, and we also have something we are calling a fine jet B. So this is our fine jet B. So you simply release some potassium permanganate slowly, that is into your fluid. Then of course you observe the formation of streamline. So we are saying that a reservoir A contains potassium permanganate solution, which is released in controlled amounts into the water flowing through a cylindrical glass jacket C by a fine jet B. So the speed of water through C is varied by the clip D, such that when you release a lot of water, obviously when you make D loose, it releases a lot of water, increasing the speed of flow of water in this particular glass tank C. But when you tighten its D, that is the tap at D, the speed of water is reduced. So we are saying that the speed of water through C is varied by the clip D. If a small amount of water is allowed to flow out through D, then a fine colored stream is observed along the tube C, which indicates that a steady flow is actually taking place. So when you tighten this one, actually the fluid in this particular C, that is glass tank C, will flow slowly. That is, when you tighten this end here, the fluid will flow slowly, and therefore the color of potassium permanganate, that is the pink color, will be observed to form streamlines, that is straight lines moving slowly. But if you try, but when a large amount of water is allowed to flow out, the velocity of water in the tube C increases rapidly, and this breaks the colored streams, indicating the turbulence has set in. So When you tighten D, the speed of the water becomes slowly, and the colors of the pink color of potassium permanganate will be seen flowing in streams, that is in straight lines. But when you release or when you loosen D, actually the water starts flowing out very fast, and that means the speed of the water in this particular glass tank C will be very high. And when the speed is high, that means the turbulence will be the turbulence sets in. So that simply shows you that whenever you increase the speed of a flow that is in streamlines into an extremely higher speed, that will cause the flow to be converted into turbulence. So we are saying that turbulence sets in when the fluid flow is beyond a certain velocity called the critical velocity. So somebody can ask you this particular question, that when does a streamline flow become a turbulent flow? Somebody can ask you to give a condition necessary for a streamline flow to become a turbulent flow. So the reason will simply be it will be converted into a turbulent flow when the fluid flow is beyond a certain velocity, which is the critical velocity. So a streamline flow becomes a turbulent flow when its velocity exceeds the critical velocity. So that is the main reason. Although there are other factors or there are other conditions that can also cause a turbulent flow to become a streamline flow to become turbulent. And the other conditions are, one, when there is an obstacle on the path of the fluids. Because remember, when there is an obstacle, it might resist the flow of the fluid, leading to eddies. Then also the other condition is when there is a sudden change in the shape of the pipe, such that maybe the pipe comes into a bend, leading to formation of eddy currents or reduction of the speed of that particular flow. So I've told you that if you are asked to give one reason why or one condition necessary for a streamline flow to become turbulent, you will say the condition will be when the speed of the fluid exceeds a certain critical value, or when the speed of the fluid exceeds the critical velocity, or simply when the fluid's velocity exceeds the critical velocity. So that is the main reason. But if you are asked to give maybe three reasons three conditions necessary for a streamline flow to become turbulent, you can say, one, when the speed of the fluid exceeds the critical velocity; two, when there is an obstacle on the path of the fluid; then three, when there is a sudden change in the shape of the pipe. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that the start is what stops most people. Don't be most people. So the quote is simply encouraging us to start working on something that we've been postponing for a long time. Most of us are waiting for the circumstances to be perfect or for the resources to be adequate in order for them to start pursuing their dreams. The truth is that perfection is an illusion. That is, it's not a reality. That is, circumstances will never be perfect and resources will never be enough for you to start pursuing your dreams. So, what you need to do is to take the current imperfect circumstances and perfect them. That is, you need to start doing what you can where you are with what using the resources that you have. Also, remember that your dreams could be something small, such as adhering to your study timetable, starting a small business, recording a song, practicing football skills, developing a website, publishing a book, establishing a charitable home for disadvantaged members of our society, etc. And lastly, recall that unless you develop enough courage to take the first step of starting, you will never know how far you could have reached. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. Thank you very much. In case you are new to this channel, kindly hit that subscription button and also turn on the notification bell so that whenever I upload a new video, you'll be the first person to get a notification. Also, thank you very much for those who have subscribed, and even for those who have not subscribed but they keep coming back to view my videos. I do not take that for granted. Kindly just find it good in your heart to hit that subscription button so that you help me grow the channel. Also, if you know anyone or any student that you honestly think will benefit from this content, kindly do me an act of kindness and refer them to this particular channel. Thank you very much. Let's meet in our next class.